I know several of you probably thought that I had forgotten about this problem, and I had actually worked it out after we discussed it the other day. I believe that was Thursday, and had every intention of putting this video up Friday, but the chaos of things that are going on took that time away from me. So I'm going to go ahead and do this for you now, and this is a specific question that Brandy had asked about the test. I believe it was question number 24. And we're asked to find or express the area of a rectangle inscribed inside a circle of radius 18 units. Express the area of that rectangle all in terms of x, or as a function of x. So I came up with a better explanation than what I was trying to do while we were meeting together on Thursday. And with this explanation, I think you'll find that it's a whole lot easier now. And this just also further illustrates the point that with mathematics, especially from this point forward, in this class and any other class, there are going to be multiple ways you can go about solving these problems. When we were discussing it together, I was looking at the big picture, but I was only looking at the upper half of the circle and trying to just double that, and that would have worked because obviously we would the process would still be the same. Then towards the end of my explanation, I was looking at just a quarter of the rectangle and trying to quadruple that. Again, that would have worked just as well, but I came up with a much simpler way of doing this, and I'm going to illustrate that to you now. So we already have, here's our rectangle inscribed within our circle, and we have a radius of 18 units. So if our radius is 18 units, that implies that we have a diameter of 36 units. And remember, our diameter would be from this upper right vertex to the lower left vertex of this particular rectangle. Now the width, we're just going to call it x, and the height of this rectangle we'll call y. Now, if you'll notice, let me change my color here. We have that is terrible. Let's try a different color. Nope, that's not going to work either. We have this rectangle, or this triangle, and it's a right triangle that we have formed by drawing that diameter through the two vertices of the rectangle. And with a right triangle, we know that we can find x and y using the Pythagorean theorem, and we would have x squared plus y squared equals 36. And this doesn't matter what x input we have, we're just talking about the general area of this particular rectangle. So x squared plus y squared equals 36. I think we can all agree on that using the Pythagorean theorem. Then we want to get y by itself because we want everything to be in terms of x. So our first step would be to subtract x squared. And then our next step would be, sorry, I forgot to square this 36 squared. So 36 squared is 1296 minus x squared. And then we take the square root of both sides. And there is our height. That's the value for y written in terms of x. Then we can go to our area formula. Remember, area in this particular rectangle would be x times y. That's length times width. So now we can just rewrite this as x times our value that we just computed for y, which is 1296 minus x squared. And there is our area written entirely in terms of x. So I hope this explanation makes a lot more sense. Again, if you have questions throughout the day, don't hesitate to contact me. I'm going to be busy with getting notes and videos ready for this upcoming week. I know some of you are going to be coming back, so I'm trying to make arrangements for all of that. So I hope everybody has a great day, and just let me know if you need anything else.